All right, coming to 44 and 45. Some calculators, you can plug this right in if you know how to use your calculator correctly. We learned the change of base formula, which really tells us we can change any base that we have into a base that we want. And we do that because our calculators have log base 10, and so we can change these. So if we have log with some base of some number, let's call it m. So let's say we're given something like this, which both of these equals those forms. We can simply write that as, or it's equal to, log of m over the log of b, and that's that common log with the base 10 in there. So on your calculators, you can type this in. The way that I remember this is physically, when we write something here, the b is lower, so it needs to go in the lower part of the fraction. So over here, we're going to write log of 5.6 over the log of 4. Now make sure you know how to use your specific calculator. On these calculators, what you need to do, or most calculators, most handheld calculators, you just type it in straight across, log of 5.6. You usually have to end the 5.6 with a parenthesis and then divided by the log of 4. With these calculators, you actually type in 5.6 first, hit the log. It actually has the 10 here. So that's that. And then we're going to divide that answer by, and we're going to type in 4 log, so it's going to divide by that whole thing, and then we can hit enter equals. So don't put 0.6, that's actually log base 10 of 4. We need to hit equals to actually get the answer, and so the answer is 1.24. It says round to the nearest thousandth, so that's the third decimal place, so that's going to round to 1.243. So make sure you are able to use your calculator to get this answer. The next one here, same idea. We'll do log of 24 over log of 2. So I'm going to clear this out. So we want to type in 24 log base 10 divided by 2 log base 10. And again, we have the equals after that. So this is 4.585. 4.585. I do want to mention we also can use natural log, which I know we didn't talk about this a lot, or maybe not at all in some of the classes. We got natural log of 24. So you can do common log or natural log. Here's natural log, it's this ln. So we could have done, I'm just going to show you, still get the same answer, 24 natural log divided by 2 natural log equals still the 4.585. So you can do either one. Don't mix the two together, of course, but either one will work. Let's put this away for now. We might bring that back later. We're solving now exponentials. Again, we want to get the exponential by itself, so we're going to subtract 2 from both sides. And we have 5 to the n minus 2 equals 79. Now what we're going to do is we're going to change this to log form. So we're going to change it to log form. So log base 5, because the base of the exponent is the base of the logarithm, of 79 is equal to n minus 2. And now once again, I'm going to pull the calculator out in a minute, and I'm going to think of this. I'm going to use that change of base formula we just used. We're going to type in log of 79 over the log of 5, because we want to find out what number this is equal to, equals n minus 2. So bringing back the calculator, let's clear this. We need log of 79, so 79 log divided by 5, hit the equal sign. So this left side is 0.27149. Now I'm going to 10 thousandths in this case, equals n minus 2, simply adding 2 to both sides. And we find n is equal to 4.7149. And that's our answer. We'll keep this here to use in a minute. Same process, same idea. We'll add 6 to both sides. We get 7, oops, cross that out, to the n minus 9 equals 37 plus 6 is 43. Change to log form, so log base 7 of 43 equals n minus 9. Going to come put this in my calculator. I'm going to put in the log of 43 over the log of 7. You get a lot of practice with this change of base formula. And if you don't know, it's really going to hurt you. So let's try this. This is 43. Log of 43 divided by the log of 7. And we get 1.9329 equals n minus 9. We're going to add 9 to both sides. So adding 9 to both sides gives us 10.9329. And the last part of logarithms is graphing logarithms. The points that go on the parent function of these. So parent function points. So we're going to do the same thing. We'll sketch the parent function and then we'll shift it left or right and up or down. Logarithms are inverses of exponentials. So exponentials went through 1, 0. Well, this will go through, sorry, exponential went through 0, 1. Logarithms will go through 1, 0. Base 1 and the reciprocal of the base, negative 1. And it will have a vertical asymptote. At the y-axis. Now again, this is just the parent function. Things can get shifted, and they do in both of these. So for this one over here, we'll do this in red. The points of the parent function will be 1, 0, 1, 0, base 1, so our base is 3, 3, 1, and the reciprocal of the base, so 1/3, negative 1. So 1/3, negative 1. I'm going to sketch this one, or attempt it. I've been struggling. But we're going to sketch this graph. It comes up. It's not supposed to hit the y-axis. Comes around kind of like that. That was off. But that's just the basic idea. So this red part right here is really just log base 3 of x. And now we want to do some shifting. This is going to be right 1 and down 2. So take each of these points, right 1, down, well, let's start with this one, right 1, down 2, right 1, down 2, take this point, right 1 and down 2. Even this vertical asymptote gets moved right 1, moving it down 2 doesn't really do very much, but it does get moved to the right. So that's going to be the new asymptote, and you can now kind of see what this graph will look like. It'll go through those 3 points. Shouldn't have that little waviness in there, but I have trouble with this program. So that black one is a representation of this graph right here. Over here, it's really the same idea. I didn't mean to, but it actually even has the same base. So this red one here would be the parent function for that. So we can graph those same 3 red points, 1, 0, 3, 1, and 1/3, negative 1. But then this is going to be right 1 and up 5. So take each point, go right 1 and up 5. This one, right 1 and up 5. Right 1 and up 5. The asymptote would also move right 1, so it's going to be right here. This line, and it will come up, go through these points. And there's the graph at that one. So it's graphing logarithms.